Assalamu alaikum dear students. Today we are going to discuss how to find the distance between the point and the straight line.
Let p of x1 y1, that is point, we have a point with coordinates x1 y1, and we have a line which is in general form, that is ax plus by plus c equals to 0. That is, we have this line and we have this fixed point p of x1 y1. Now we have to find the distance. What is the distance between this point and this line? Actually, distance between these two, that is point and the line, is the perpendicular distance between the two. Now this line intersects the x-axis and the y-axis. So how to find the coordinates when we put y equals to 0? That is, when y equals to 0 in equation first, we get x equals to minus c by a. That is the coordinates of point q, that is the point of intersection between the x-axis and this line, or minus ca and 0. Similarly, point on y-axis is, or in its coordinates by substituting x equals to 0, is 0 minus c by v. So these are the 2 points, point R and point Q. Now this point P is fixed. From P, draw a perpendicular PM on this line. Let us assume that this perpendicular distance, that is PM, is d. Now we have to find this PM. Now when we join this PQ and PR, now triangle is formed PQR. Now area of this triangle is given by 1 by 2 base into altitude. Now altitude is here PM and base is here RQ. So which implies that PM, that is this perpendicular distance, is twice the area of triangle upon RQ, while RQ is. Now we will use the concept of earlier concepts about the area of the triangle whose vertices are given. Now vertices is x1 y1 and x2 y2 is here 0 minus cb, and x3 y3 is minus ca and 0. So using in the formula of 1 upon 2 x1 into y2 minus y3 plus so on to this, we simply get 1 upon 2y mod of ab, that is product of ab into x1 ac plus c square plus y1 bc. Now this is the area. Now similarly, distance between these 2 points with the coordinate 0 minus cb and minus ca0 is given by distance between 2 points, that is root of c square upon b square plus c square upon a square, that is simply c upon ab into root of a square plus b square. Now when we substitute in the equation, we simply get modulus of ax1, this modulus of ax1 plus by1 plus c upon root of a square plus b square. So this is the required distance. Here this ax plus by plus c is the distance in this equation. So simply substituting or replacing x by x1, y by y1, find the modulus of this very number and dividing it by the square root of coefficient of x square plus coefficient of y square, because here a is coefficient of x, b is coefficient of y, and this y. This means that required distance between this point and the line ax plus b1 plus c equals to 0 is simply modulus of substituting the value of x1 equal x in place of x and x2 in place of y, and dividing by the under root of sum of the squares of this coefficient of x square and coefficient of y, that is ax1 plus by1 plus c upon root of a square plus b square. So this is the required distance. Now here, like example, find the distance between 2 5 and the line 3x plus 4y minus 3 equals to 0. So simply put x1 equals to 2, y1 equals to 5, substituting in this. Here a equals to 3 coefficient of x, b equals to 4 coefficient of y. Substituting in here, we simply get 23 upon 5. The second concept is how to find the distance between the two lines. You know that in plane we have two types of lines. One is consistent and inconsistent lines. Consistent means which intersects at one point, and we have further two types of inconsistent lines. Those which do not intersect means those which are parallel, and those which intersect but at infinitely many points, that is this one.
Now, in these two cases where the lines intersect either at one point or at infinitely many points, in both cases the distance between the two lines is zero. Distance means the smallest distance. Here distance is same throughout and is non-zero. How to find this? Now, in this case, when we have to find the distance between two lines, either it is zero. If it is non-zero, then they are parallel. When they are parallel, this means that their slopes are equal. When the slopes are equal, this means that we can write the general forms in this slope intercept form, which are of the form of y equals to mx minus 1, y equals to mx minus c1, y equals to mx minus c2, because mx and mx, m is slope which is same, c1 and c2 are the constants. Now let's assume that find any arbitrary point or find fixed point on line L1 or line L2. Here we will find the point on L1. Now when it intersects at when y equals to 0, x equals to minus or simply c1 upon m. This means that this c1 upon m0 is arbitrary point on L1. Also, the distance is same throughout, which implies that we will simply find the distance between this point and the line L2. Now we know that the distance between this line and point is given by d equals to under root of ax1 plus by1 plus c upon root of a square plus b square. So here x1 is this, c1 by m, y1 is 0. General form of this line is given, or from this slope intercept form we will change it into the slope intercept form as this mx minus y minus c2 equals to 0. When we substitute, we simply get d equals to modulus of c1 minus c2, that is difference between the intercepts, upon 1 plus root of 1 plus m square is the distance between the two lines when they are in the slope intercept form. But when they are in simply general form, then the distance between the two lines is simply given by modulus of difference of the constants upon coefficient of x plus coefficient of y square root, that is root of a square plus b square. So this is the required distance between the two parallel lines. This is either 0. If it is 0, then there are two possibilities: either they intersect at finite point, means one point, or they intersect infinitely, means those are inconsistent lines, means dependent lines. Inshallah, in tomorrow's video lecture we will continue this very topic and do few problems on this, how to find distance between the point and the distance between the two lines. So thank you.